So I'm going to talk a little bit about Hurricane Irma because, like Hurricane Harvey, this is quite an interesting storm for a multitude of reasons. But firstly, let's cover exactly how strong it is. So I've got Wonderground up because this is a good sort of hub for all of the data. So I'm currently looking at an infrared satellite image. You'll notice how clean that the eye looks in that. So the eye has warmed up significantly over the last few hours, and it's very symmetrical, which is indicative of a very strong storm. Now, it turns out this storm is actually, according to the latest drops on data, has a minimum surface pressure of 926 millibars and 185 mile per hour. I think that's 1 minute sustained wind. So that puts it in terms of the wind speed at I think joint second strongest North Atlantic hurricane on record. I think it might even be the strongest, depending on exactly what you would define as the North Atlantic basin. So it's certainly a very, very strong storm. In fact, actually, there's a discussion about whether or not the Saffir-Simpson scale, which categorizes these hurricanes, whether or not to introduce Category 6. And a Category 6 storm would have wind speeds of 175 miles an hour or greater, and you can see this one is 185. So if that category existed, it would be a Category 6 storm. The reason that Category 6 doesn't exist is not because there would be no storms that would meet that benchmark, but because that by the time you get to the Saffir-Simpson scale is meant to express numerically how much damage potential the storm has. And the reason why there isn't a Category 6 is because at the point you get to Category 5, it annihilates pretty much everything. It doesn't matter how well the structure, how well a building is constructed, a Category 5 will level it to the ground. So there isn't really any need for a Category 6 for that reason, because the damage potential of a Category 5 is already extreme. So there's not too much of a need for a distinction. Nevertheless, this is just sort of to emphasize exactly how strong Hurricane Irma is. It's quite unprecedented. So I've been sort of tracking how strong it is, and this is quite a useful website. This is this uses the Dvorak technique, which I might have mentioned before when it came to Harvey. So the Dvorak technique is quite interesting. So it uses the satellite imagery to come up with an intensification, come up with intensity information from the satellite by looking at the cloud patterns. So essentially, a storm with a more symmetrical looking eye, for example, you can tell that it's stronger just by looking at it. And from that, you get, you can use these computer algorithms to automatically determine how strong the storm is just by looking at the satellite data. And then this can be used in conjunction with aircraft dropsondes and so on to give you a more complete understanding of how strong the system is. But I quite like this because it gives you a more up-to-date understanding of when the storm is intensifying and so on. So at the moment it's got a T rating of 6.6, which roughly corresponds to a strong Category 4. Now I know that Hurricane Irma is currently rated as Category 5, but the reason that there tends to be somewhat of a lag between I guess the measurements and the Dvorak, which tends to be ahead. I mean, this isn't perfect, so it might also be the fact that the Dvorak seems to be underestimating the strength, but 6.6 is still a strong Category 4. But anyway, here's the sort of time series of the Dvorak rating over time. So you can see that, again, these T numbers, there's no direct relationship between the T number and the Saffir-Simpson number. But just to sort of give a rough indication, I think 4.5 is about Category 3, sort of 5.5 is about Category 4, and Category 5 is about 7. So I mean, it's sort of And again, I think it's been underestimating it to some degree. But another useful thing about this is you can see sort of these periods when it intensifies and then it weakens, and then it intensifies again and then it weakens, and it intensifies and it weakens. Now, I believe the reason for that is that the hurricane was undergoing these eye wall replacement cycles, which I've mentioned before. So essentially, what tends to happen is that outside of the initial eye, another eye starts to form that's outside of that, and then the inner eye gets destroyed. And during that process, the wind fields expand, but you also get a slight reduction in the maximum wind speed. So these eye wall replacement cycles show up as this temporary period of weakening. And you can see that there's been several of these. So I think there's 1, 2, 3, 4, 5, 6. So I guess there's been 6 eye wall replacement cycles, around about 6. So and again, strong storms tend to do this as well. So I suppose that's not surprising. Weaker storms don't tend to undergo the eye wall replacement cycles to the same degree. Okay, so I'll look at the track, which of course is important, where exactly the storm is going to go. So I mean, the wonder of ground is useful because it assembles all this information. So the track is sort of consistent in that it moves sort of just to the north of Cuba, or maybe even potentially landfalls there. That's a little bit uncertain, and then sort of curves sharply to the north, which is I guess due to the synoptic environment. And then once it curves to the north, I imagine it'll start moving sort of in a northeastward direction. But again, it's uncertain, and whether or not it landfalls in Florida is still up for debate. And by the time it gets here, it may not be a Category 5 anymore. It may have weakened, and whether or not it weakens will, I guess, depend exactly on the track, because see, at this point the environment is very, very good. So in terms of the sea surface temperatures are very high. The ocean content therefore is also quite high, so we're getting very strong surface fluxes, and the wind shear is also very low. So wind shear is the property of the differential wind speed with height. So high wind shear would be the wind speed changing rapidly with height, and what that tends to do is when you get significant amounts of wind shear, it tends to weaken hurricanes. But the point being is that we're currently in for the entire duration of this path, Irma is going to be in a very low wind shear environment, and also in an environment with very high sea surface temperatures, somewhere in the range of about 29 to 30 degrees, which is very high. So there's in terms of the environmental conditions, there's very little to actually weaken the storm. So there's still potential for the storm to intensify even further. So the only thing that can really weaken the storm is actually any kind of landfall event, particularly over the mountainous terrain here, and that would definitely weaken the storm. So it really comes down to exactly which path the storm takes, whether or not there's going to be some kind of land interaction that weakens it. Of course, moving over islands will also have a similar, albeit lesser, effect. I would also like to point out, if we look at the current activity just briefly, that there's a second one coming in behind called Tropical Storm Jose, I think it's pronounced. And I'm looking at this one because it's taking a quite similar track, although this one is curving to the north rather sooner. So I mean, I don't think this one is going to be a threat to the same degree as Irma, but there's a possibility that this can move over the same islands, which again is going to limit the potential for any kind of long-term recovery from Irma. So that's also something to bear in mind. But there's no chance that Jose will be anywhere near as strong as Irma, for the simple reason that when hurricanes move over the water, they tend to induce mixing at the surface and bring colder water from the lower depths. So when you get one hurricane following after another one, it doesn't really matter if the environmental conditions are good, because the sea surface temperature is already going to be lower. So Jose has nowhere near the potential that Irma does, but nonetheless, it's something that should be still watched. So coming back to Irma, and so again, so these are the ensemble models, which basically is the so the ensemble suite is basically taking all the models and then applying perturbations to it, small perturbations to changing conditions slightly, and then running the model and seeing how that affects the track. And then you can get a sort of range of possible different tracks from doing that. This is the GFS suite, which is somewhat inferior to the European one, but it's still a good idea to look at the ensembles, and you can see that there's a variation in the track to exactly how far north it is, and then I suppose, but basically all the ensembles seem to agree that it's going to make landfall in the US at some point, but exactly how strong it will be depends on its track, because again, some of these ensembles take it over these islands, which would cause the land interaction and the weakening and so on.